Let's look one more time at the Henderson-Hasselbalch equation. We saw it in the carboxylic acid chapter. We essentially have to go back to this equation every time we talk about what form an acidic or basic compound exists in physiological pH, because that equation will tell us the ratio of base to acid when our compound is buffered in a certain pH environment. So physiologic pH is around 7.3, and as long as you're healthy, that number doesn't change much. So the compound we have, if we've got an amine, having amines will not affect the body's physiologic pH. Rather, the substance itself will react to the surrounding pH conditions. And remember, for a conjugate acid-base pair to be at a 1-to-1 ratio, so if I were to, for instance, have equal amounts of an amine and its ammonium ion, the pH would have to be equal to the pKa. So if I had just regular old ammonia and ammonium, that pKa is around 9. If pH was 9, we'd have 1-to-1 ammonia and ammonium. Any pH more acidic than that will cause the conjugate acid to be favored. And remember, it's favored by 1 power of 10 for each pH unit. So if I go down acidic by 1 pH unit, we favor the acid form by 10. If I go more acidic by 2 pH units, I favor the acid form by 10 to the 2, or 100. If I'm 5 pH units more acidic, I favor the acid by 10 to the 5. And vice versa. If we're more basic, we favor the base form by 10 to the whatever. So think about methylamine. Okay? Little stronger base because the conjugate acid is a little bit weaker, 10.64. Let's figure out in what form methylamine exists at physiological pH, which is 7.3. So our pH is more acidic than the pKa of the compound itself. So the difference, right, if we substitute in the Henderson-Hasselbalch equation, you can do that math if you want, but it's, just easy to think about in terms of powers of 10, right? We're about 3 powers of 10 more acidic, right? 10.6, 9.6, 8.6, 7.6. So a little more than 3 powers of 10 more acidic. That means the ratio of base to acid will be some number less than 1, which means the acid is favored by more than a factor of 10 to the 4. And that's the case for any amine whose pKa is greater than 7.3. So ammonia, any alkylamines, in each case, their acid form will be favored. So methylamine, its form, right, by a vast majority, is CH3NH3 plus, is the dominant form. It's the protonated form, so it does not really exist very much in a neutral form at physiological pH. It turns out that pyridine, though, right, its pKa is 5.25. If I'm at physiological pH, I'm more basic than that. So it'll have a 100-fold, right, 10 to the 2-fold excess of the neutral base form. So remember I said what pyridine is. It's like benzene just with nitrogen. Here's pyridinium. Okay. The neutral pyridine will be favored at physiologic pH. Based on pKa data that you'll be given, you should be able to tell what form a certain amine is at physiological pH. By the way, you should probably know those general pKa rules that I said before, where regular amines and alkylamines are 9 or 10 or so, aromatic heterocyclic amines are 5 or less.